All right, to simplify square roots that have a negative, first off, you can't do this in your calculator. So what we want to be able to do is simplify this and understand what the negative means. And what it means is it's an imaginary number since it can't be done in your calculator. So that negative actually becomes an I. We call it an imaginary number. So if we have just the square root of 27 and we want to simplify, now you can press that in your calculator and get the answer. But we can go, I'm going to go through the process so you can see it being done as well. So if I go through the process, I'm going to do a factor tree, and I'm going to do it by 2s and 3s since it's odd. I'm going to divide by 3, and then I'm going to go all the way down to prime numbers. And every time I have a pair of numbers, one of them come out of the radical sign. So this is a pair of numbers. So one of them will come out of the radical sign, but this other number that's not a pair, the 3, will stay in the radical. So outside I already have an I. So if I bring out one of the 3's and I have my I, what's left over in the radical is the 3 that doesn't have a pair of numbers. So this is simplifying. Now your calculator will do all the parts without the I. So if you understand that we have a negative in the square root sign, you can pull that out first. So let's go to our second problem here. If I pull that out first because of the negative and leave the 216, you can then press that in your calculator and get the answer with the I. But I'm going to go through the process. If I go 2, that will go in 108 times, and then I go 2, that's 5, 4, and I go 2, that's 27. 27 is 3 and 9, and 3 and 3. So now that I've broken it down, I can look for every pair of numbers, so one of them will come out. So here's a pair of 2's on the end of mine. Here's a pair of 3's. So I can take a 2 and a 3 outside the radical, which will make 6, and the I is already there. And then the radical is left with a 2 and a 3, and this is all multiplication, so I end up with 6. Once again, the radical 6 can show up on your calculator. If you use it, you just have to understand what the negative means. So that's simplifying radicals. Now, we have to understand is sometimes when we have the letter I, it means or equals something. If I just have an I, obviously it's an I. But if I have an I squared is -1. And if I have an I cubed, I get a negative I, and I to the 4th power is just a +1. And if you work on those every 4, you can figure out what any I to a power is simply by looking at these 4. So let's look at product, which means multiplication, and see how this is puts in use. So if I do my product, means I'm going to multiply. So if I multiply my numbers, that's a -15. If I multiply my letters, that's I to the 2nd power. Well, I to the 2nd power actually equals -1, so this part is a -1. So I'm going to replace it. And if I take -15 times -1, I actually end up with a +15. So the answer to this simplified is 15. Now let's go to the process where we don't have I's that are showing, but they end up as I's in the problem. So if I take out the I of my radical 6, and if I take out the I, because it's negative radical 15, I can multiply the I times the I, which is I squared, and I'm going to leave it as I squared right now. And then I can do the product of 6 times 15, which is 390. And then I can simplify all of this. So I'm going to go through the simplifying the radical 90. I'll do that here on the side. So I'm going to go my factor tree, and I'm looking for pairs of numbers, and my pair of number are 3. So the 3 is going to come out, but we also need to understand what the I squared means. Well, the I squared equals a -1. So if a 3 comes out and a -1, I'm going to end up with a -3. And then what's left over is what's inside, or doesn't have a pair, so 2 and 5, which is 10. And so we end up with a -3 radical 10 as the answer. So there's a lot of process going on here. You have to deal with the I's, and then you have to deal with the numbers and simplify both. So we're going to use that knowledge a little bit to solve where we have imaginary solutions. So to solve this, I'm going to get the x by itself. So I'm just going to write the problem, x squared plus 64 equals 0. So I'm going to minus the 64 to both sides of my equation. X squared equals -64. And to get rid of a square, we take the square root. So if I take the square root, so that gets rid of the square, leaves me my x. But this then leaves me an issue of a negative. We already know that anytime you have a negative in the square root, we pull that out as an I. And then you have your 64, which happens to be 8 if you do it in your calculator. So our answer is 8I. And because we took a square root sign, I forgot that we needed to make sure that we have a positive and a negative. So we have a positive negative 8I. So technically my answer is 8I and negative 8I. So let's go through that process again with this equation. 4x squared plus 100 equals 0. So if I'm going to write that equation out, I'm going to solve by getting rid of the number that doesn't have the variable first. By getting rid of, I mean adding or subtracting. And then I'm going to divide by 4. So x squared equals a negative 25. And now I take the square root. And anytime we take the square root, we'll have a plus minus. So this will leave me the x plus minus. And we know we're going to have an I because of the negative. And the 25 will be 5. So writing this properly, I always write the number first, I. So I have a plus minus 5I.